For 5 long years, a biologist named Regine Gries gave her own arms as food for more than 1,000 bedbugs every week, adding up to over 180,000 bites. That's because she and her husband were determined to conquer the global bedbug epidemic. They worked tirelessly until they finally developed the world's first affordable and effective bedbug bait and trap. But what made these bedbugs so special? Why did they become such a big problem? And how does their new invention work? Let's jump in. Bedbugs are small insects that feed on blood. You can usually find them on furniture or walls in places like beds, headboards, dressers, sofas, and behind pictures or mirrors. Bedbugs are also really good at hiding. They can squeeze into cracks smaller than the width of a dime. They prefer to live close to where their food source sleeps, making bedrooms the ideal spot for them to make themselves at home. They're also great at traveling. They often hitchhike on luggage, clothing, or furniture. They've even been known to travel through walls. So if you suspect you have bedbugs, chances are you do. Even trained inspectors miss them half the time because they're so well hidden. Bedbugs were around long before humans built our modern buildings. The earliest record of bedbugs comes from 2000 BCE, when Egyptians mummified one that was found inside a tomb. They've traveled on ships with us, following explorers across the globe. For most of history, we welcomed them because they helped keep other insects away. In fact, during World War II, soldiers slept with bedbugs in their barracks. The bedbugs kept malaria-spreading mosquitoes away. It wasn't until we started building tall office buildings and skyscrapers that things changed. As cities grew, more people started living together in tight quarters. This meant more people to feed on, but it also meant more competition between species for food sources. This put pressure on bedbugs to adapt. That's when they began moving from their friendly coexistence in homes to being plain old pests. And then, in the 1950s, things got really bad. Pesticides known as pyrethroids were invented. These quickly became popular because they didn't seem to affect humans or animals the way that older pesticides had. But these same pesticides would later be linked to serious health problems. So their use was banned in 2001, but by then, bedbugs had already learned to resist them. The ban left pest control professionals without an effective weapon to fight the growing bedbug problem. Since then, infestations have increased 1,000%. Bedbugs are now a worldwide problem. They infest hotels, apartments, libraries, schools, and even public transit. Not only that, but they're extremely hard to get rid of. Once infested, a piece of furniture will always have a little stash of bedbugs in its cracks, no matter how many times you clean it. And since they can travel so easily, you can quickly go from having none to having millions of bedbugs in just a few days. Infestations are associated with poverty, homelessness, unsanitary conditions, and filth. But today, 30% of all calls to pest control companies are about bedbugs, and they don't discriminate. You can have the cleanest house in the neighborhood and still end up with bedbugs. The problem is that we didn't have an effective way to detect them early, and if we didn't know we had them, we couldn't get rid of them. That's where Regine and Gerhard Gries come in. Regine is a biologist at Simon Fraser University in British Columbia, Canada. Her lab focuses on chemical ecology, which is basically studying how chemicals in the environment influence living things. And for the last 20 years, she's studied bedbugs. She has 2 insect-rearing colonies at the university, one of which contains 2 million bedbugs. The second one holds 750,000. To study these colonies, Regine feeds them herself. She raises the bedbugs on chicken, beef, and rabbit blood. She puts a small amount of blood on a paper towel and then gently nudges the bugs towards it. Once they start eating, she removes the towel before they can eat it all so that she can reuse it. And she does this twice a week for thousands of bedbugs. Every week, Regine gives her arms to the colony as food. She says the bites hurt, but she doesn't feel anything after a while because of all the painkillers she takes. Over the course of her research, she has given her arms to over 180,000 bites. Of course, she's not doing this alone. A team of graduate students and technicians help her raise and feed the bedbugs. But even still, that's a lot of bedbug bites. All this was part of the search to find a way to fight the bedbug epidemic. But they weren't interested in a pesticide. They wanted to find something else. Because bedbugs are so good at evolving, they'll eventually become resistant to any pesticide that we invent. Instead, they wanted to learn how to lure the bedbugs away from humans. This idea came from studying other insects. For example, fruit flies are attracted to ripe fruit, so we can design traps that mimic the smell of ripe fruit to catch them. If they could do this for other insects, why not bedbugs? There was a problem though. They needed to figure out what the bedbug's idea of a safe haven smelled like. They tried all sorts of things, including dog and cat urine, cedarwood oil, geranium oil, cloves, and even the pesticide permethrin. Nothing worked. They needed more information. So Regine took a job at the Max Planck Institute in Germany, working with the famous scientist and Nobel Prize winner Johann Rauschenbauer. There, she learned about a machine called a gas chromatograph, mass spectrometer, which can identify chemicals at incredibly low concentrations. With this machine, she could analyze the scent of bed bugs and potentially find out what they're attracted to. But there was another problem. She needed live bed bugs to test, but Germany wouldn't let her bring her bed bugs with her. So she sent them there instead. She packed them carefully in plastic containers, enough to ensure their survival, but also enough to make sure that no bed bugs could escape. Then she shipped them off. However, upon arrival in Germany, it was clear that some of the bed bugs had died. Regine didn't know why. She thought that they might have been crushed in transit, but that wasn't the case. She looked under the microscope and realized that the dead ones had been chewed in half. Turns out that the air in the unsealed plastic container was too dry, and the bed bugs began cannibalizing each other. Cannibalism! All this time and money wasted, and the research was set back months. But Regine figured out what went wrong. She sealed the containers better next time. Finally, she could move forward. She flew to Germany and collected the live bed bugs. Then she brought them back to Canada and started the experiment. She placed live bed bugs in a chamber and recorded the chemicals they released. She repeated this process with different chemicals and identified the most common scent bed bugs release when they feel threatened: histamine. Histamine makes bed bugs sluggish, which helps them avoid predators. She hypothesized that if she combined histamine with the right chemicals, it would attract bed bugs. But first, she needed to find out what those chemicals were. She teamed up with chemist Robert Britton at the University of Alberta and a team of students. They spent 3 years testing hundreds of potential chemical combinations. Each combination consisted of 6 chemicals, 3 of which were unknown. They had to test every possible combination of these unknowns to see which one attracted the most bed bugs. This meant going through 720 different possibilities. Then they added histamine to the winning combination. Finally, they tested each variation in the lab. Only 4 showed any promise. Then they had to repeat this whole process again. In the end, they narrowed it down to one perfect mixture of chemicals. When bed bugs smelled it, they became sluggish, just like they do when they encounter histamine on their own. Now they had the key to solving the bedbug crisis. They just needed to scale it up. They partnered with Contech Enterprises, a Canadian company that develops and manufactures technologies for agriculture and public health. Together, they created the world's first affordable and effective bedbug bait and trap. The traps are made of cardboard or plastic and filled with a chemical cocktail that attracts bed bugs. They come with a glue trap to capture the bed bugs and a sensor that detects carbon dioxide, which increases in concentration as more bed bugs enter the trap. This means the sensor doubles as a way to monitor the severity of the infestation. Right now, the sensors are analog, but the company is looking into making them digital so they can send data to your phone. This invention is expected to be available soon, and it's a big deal. Before this, landlords and tenants would spend thousands of dollars on expensive dogs to sniff out bed bugs. Even then, the dogs would only tell you if you had them, not where. Now you can simply place a few traps in the affected areas and monitor them. If the sensor turns red, you know you need to call a professional. It's an exciting time for Regina and her team. But when asked about her favorite part, she doesn't hesitate. Being able to take a bath without getting bitten is probably the best thing about this research. What do you think? Would you try this new trap? Let me know in the comments below. And as always, thank you for watching.